Pool pumps, spa pumps, and heaters are generally treated as distinct loads and must be incorporated into electrical load calculations. It is important to acknowledge that local electrical codes or interpretations of the National Electrical Code, or NEC, can differ. Therefore, consultation with local authorities and inspectors is crucial to ascertain the precise requirements applicable in a specific geographic region. The NEC serves as a foundational standard, but its application can be influenced by local amendments and interpretations. These variations can stem from specific environmental conditions, infrastructure characteristics, or local policy decisions. Understanding these local nuances is essential for ensuring compliance and safety in electrical installations. The optional calculation method, which excludes doubting factors, typically applies only to specific load types and may not extend to pool pumps, spa pumps, or heaters. The NEC outlines specific conditions and load types eligible for this optional method. A careful review of the code language is paramount to determine applicability. In addition, seeking clarification from local authorities can prevent misinterpretations and ensure adherence to the correct calculation methodologies. Electrical load calculations for pool and spa equipment typically involve several factors. Firstly, determine the voltage and amperage requirements of each piece of equipment. This information is usually found on the equipment's nameplate. Secondly, calculate the total wattage for each piece of equipment by multiplying the voltage by the amperage. Thirdly, consider any applicable demand factors, which allow for a reduction in the calculated load based on the likelihood of all equipment operating simultaneously at full capacity. Fourthly, factor in the conductor and capacity requirements, ensuring that the wiring is appropriately sized to handle the calculated load. Fifthly, account for overcurrent protection requirements, selecting circuit breakers or fuses that provide adequate protection against overloads and short circuits. In performing load calculations, it is crucial to consult the relevant articles within the NEC, particularly those pertaining to swimming pools, spas, and electrical wiring methods. These articles provide detailed guidance on acceptable practices, required safety measures, and specific requirements for equipment installation. In addition to the general load calculation principles, specific considerations apply to pool and spa equipment. Firstly, bonding and grounding requirements are paramount to ensure electrical safety and prevent shock hazard. Secondly, ground fault circuit interrupter, or GFCI, protection is typically required for outlets and circuits serving pool and spa equipment. Thirdly, wiring methods must be suitable for the wet and corrosive environment often associated with pools and spas. Fourthly, clearances from the water's edge must be maintained for electrical equipment and wiring. Fifthly, equipotential bonding is essential to equalize the voltage potential in the area surrounding the pool or spa. When evaluating heaters, it is important to distinguish between different types, such as electric resistance heaters, gas heaters, and heat pumps. Each type has unique electrical characteristics and load calculation considerations. For example, electric resistance heaters typically draw a significant amount of current and require appropriately sized conductors and overcurrent protection. Gas heaters, while primarily fueled by gas, still require electrical connections for controls and ignition systems. Heat pumps offer energy-efficient heating but have more complex electrical requirements due to the presence of compressors and control circuitry. Understanding the specific characteristics of each heater type is crucial for accurate load calculations. It is also important to consider the impact of pool and spa equipment on the overall electrical service. The addition of these loads can significantly increase the demand on the electrical system and may necessitate an upgrade to the service capacity. Factors to consider include the size of the service entrance conductors, the capacity of the main panel, and the availability of sufficient breaker spaces. In some cases, a subpanel may be required to accommodate the additional loads. Before undertaking any electrical work related to pool and spa equipment, it is essential to obtain the necessary permits from local authorities. Permits ensure that the work is inspected and complies with applicable codes and regulations. The permitting process typically involves submitting plans and specifications for review, paying permit fees, and scheduling inspections at various stages of the project. Failure to obtain permits can result in fines, delays, and potential safety hazards. Furthermore, it is strongly recommended to engage a qualified and licensed electrician to perform electrical work on pool and spa equipment. Electricians have the training, experience, and knowledge necessary to ensure that the work is done safely and correctly. They can also provide valuable guidance on code compliance, equipment selection, and energy efficiency. Attempting to perform electrical work without proper qualifications can be dangerous and may violate local codes. When selecting electrical equipment for pool and spa applications, it is important to choose products that are specifically designed and listed for those environments. Look for equipment that is labeled as suitable for wet locations or outdoor use. This equipment is typically constructed with corrosion-resistant materials and designed to withstand the harsh conditions associated with pools and spas. Avoid using standard electrical equipment that is not intended for these environments, as it may pose a safety hazard. In addition to the NEC, other standards and guidelines may apply to pool and spa electrical installations. For example, the Association of Pool and Spa Professionals, or APS, publishes standards that address various aspects of pool and spa design, construction, and safety. These standards can provide valuable insights and best practices for ensuring a safe and enjoyable pool or spa experience. It is also important to stay informed about any updates or revisions to the NEC and other relevant codes and standards. Electrical codes are constantly evolving to reflect new technologies, safety concerns, and industry best practices. Keeping abreast of these changes is essential for ensuring that electrical installations are up to date and compliant. There are several resources available for staying informed about electrical codes and standards. These include industry publications, training courses, and online resources. Many local authorities also offer educational programs and workshops for electricians and homeowners. Taking advantage of these resources can help you stay current with the latest requirements and best practices. In summary, electrical load calculations for pool and spa equipment require careful consideration of several factors, including equipment specifications, demand factors, conductor ampacity, overcurrent protection, and applicable codes and standards. Consultation with local authorities and engagement of qualified professionals are essential for ensuring compliance and safety. By following these guidelines, you can help create a safe and enjoyable pool or spa environment. When dealing with electrical installations near water, safety is paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as rubber gloves and insulated tools. Never work on electrical equipment when wet. And always test circuits with a voltage tester to ensure that they are de-energized before proceeding with any work. Regular maintenance and inspection of pool and spa electrical equipment are also important for ensuring safety and preventing problems. Check for signs of damage, corrosion, or wear. Replace any damage to worn components promptly. And have a qualified electrician inspect the equipment periodically to ensure that it is functioning properly. By taking these precautions, you can help prevent electrical hazards and ensure the long-term safety and reliability of your pool and spa electrical system. Furthermore, consider the energy efficiency of pool and spa equipment. Energy-efficient pumps, heaters, and lighting can save you money on your utility bills and reduce your environmental impact. Look for equipment that is ENERGY STAR certified or has other energy-saving features. Variable speed pumps, for example, can significantly reduce energy consumption compared to single-speed pumps. LED lighting is another energy-efficient option for pool and spa applications. And properly insulating pool and spa equipment can help reduce heat loss and improve energy efficiency. By making energy-efficient choices, you can save money and help protect the environment. In addition to the specific requirements for pool and spa equipment, it is also important to consider the general electrical safety practices that apply to all electrical installations. These include proper grounding, bonding, and overcurrent protection. Grounding provides a path for fault current to flow back to the source, helping to prevent electrical shock hazards. Bonding connects metal parts together to equalize their voltage potential, reducing the risk of shock. and overcurrent protection devices such as circuit breakers and fuses protect against overloads and short circuits. By following these general electrical safety practices, you can help ensure the safety of your home and family. Finally, remember that electrical codes and standards are constantly evolving. It is important to stay informed about the latest requirements and best practices. Consult with local authorities and qualified professionals to ensure that your electrical installations are up to date and compliant. And never hesitate to ask questions if you are unsure about any aspect of electrical safety. By taking these steps, you can help create a safe and reliable electrical system for your pool, spa, and home. It is also important to understand the difference between bonding and grounding in the context of pool and spa electrical systems. Grounding, as mentioned earlier, provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. Bonding, on the other hand, connects metal parts together to equalize their voltage potential. This is particularly important in areas surrounding pools and spas where even small voltage differences can create a shock hazard. Equipotential bonding involves connecting all metal parts within a certain distance of the water's edge, such as metal fences, ladders, handrails, and equipment housings. This ensures that all these parts are at the same voltage potential, reducing the risk of shock if someone comes into contact with them. The NEC provides specific requirements for equipotential bonding in Article 680. It is important to follow these requirements carefully to ensure safe and compliant installation. When performing equipotential bonding, use appropriate bonding connectors and conductors. The conductors should be sized according to the NEC requirements, and the connection should be made securely and protected from corrosion. Regular inspection and maintenance of the bonding system are also important to ensure its effectiveness. Check for loose connections, corrosion, or damage. Replace any damaged or worn components promptly. Furthermore, consider the use of surge protection devices for pool and spa equipment. Surge protection devices protect against voltage surges caused by lightning strikes, power outages, or other electrical disturbances. These surges can damage sensitive electronic equipment, such as pool pumps, heaters, and control systems. Surge protection devices are typically installed at the main electrical panel or at subpulse in pool and spa equipment. They divert the surge current to ground, protecting the connected equipment from damage. When selecting surge protection devices, choose products that are specifically designed for pool and spa applications. These devices are typically constructed with corrosion-resistant materials and designed to withstand the harsh conditions associated with pools and spas. It is also important to follow the manufacturer's instructions for installation and maintenance. In addition to surge protection, consider the use of isolation transformers for pool and spa equipment. Isolation transformers provide electrical isolation between the power source and the equipment, reducing the risk of shock hazards. They are particularly useful for equipment that is located near water or in wet environments. Isolation transformers are typically installed between the electrical panel and the equipment. They prevent direct electrical contact between the power source and the equipment, reducing the risk of shock if someone comes into contact with the equipment. When selecting isolation transformers, choose products that are specifically designed for pool and spa applications. These devices are typically constructed with corrosion-resistant materials and designed to withstand the harsh conditions associated with pools and spas. It is also important to follow the manufacturer's instructions for installation and maintenance. Furthermore, consider the use of ground fault circuit interrupters, or GFCIs, for all circuits serving pool and spa equipment. GFCIs are devices that detect small imbalances in electrical current, which can indicate a ground fault. When a ground fault is detected, the GFCI quickly trips the circuit, cutting off the power and preventing electrical shock. GFCIs are required by the NEC for most circuits serving pool and spa equipment. They are typically installed in the electrical panel or at the outlet. When selecting GFCIs, choose products that are specifically designed for pool and spa applications. These devices are typically constructed with corrosion-resistant materials and designed to withstand the harsh conditions associated with pools and spas. It is also important to test GFCIs regularly to ensure that they are functioning properly. Press the test button on the GFCI to trip the circuit. If the GFCI does not trip, it should be replaced immediately. Moreover, consider the use of low-voltage lighting for pool and spa applications. Low-voltage lighting is safer than standard 120 volts lighting, as it reduces the risk of electrical shock. Low-voltage lighting is typically powered by a transformer that steps down the voltage from 120 volts to a lower voltage, such as 12 volts or 24 volts. Low-voltage lighting can be used for a variety of applications, such as pool lighting, spa lighting, and landscape lighting. When selecting low-voltage lighting, choose products that are specifically designed for pool and spa applications. These devices are typically constructed with corrosion-resistant materials and designed to withstand the harsh conditions associated with pools and spas. It is also important to follow the manufacturer's instructions for installation and maintenance. Remember that electrical safety is an ongoing process. It requires constant vigilance and attention to detail. By following the guidelines and recommendations outlined above, you can help create a safe and enjoyable pool and spa environment for yourself, your family, and your guests. And always remember that if you are unsure about any aspect of electrical safety, it is best to consult with a qualified and licensed electrician. They can provide expert guidance and ensure that your electrical installations are safe and compliant. Finally, be aware of the potential hazards associated with underwater lighting in pools and spas. Underwater lighting can enhance the beauty and enjoyment of a pool or spa, but it can also pose a significant electrical shock hazard if not installed and maintained properly. The NEC provides specific requirements for underwater lighting in Article 680. These requirements address issues such as bonding, grounding, GFCI protection, and wiring methods. It is important to follow these requirements carefully to ensure a safe and compliant installation. When selecting underwater lighting, choose products that are specifically designed for pool and spa applications. These devices are typically constructed with corrosion-resistant materials and designed to withstand the harsh conditions associated with pools and spas. It is also important to follow the manufacturer's instructions for installation and maintenance. Regular inspection and maintenance of underwater lighting are also essential. Check for signs of damage, corrosion, or wear. Replace any damaged or worn components promptly. And have a qualified electrician inspect the equipment periodically to ensure that it is functioning properly. If you notice any signs of electrical shock while in or around a pool or spa, immediately evacuate the area and turn off the power to the equipment. Contact a qualified electrician to inspect the equipment and correct any problems before resuming use. By taking these precautions, you can help prevent electrical hazards and ensure the safety of everyone who uses your pool or spa.